Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Let's solve this question. Find the limit of this rational function. If we see here, the highest power of x in the numerator is 3, and the highest power of x in the denominator is 2. So in this case, if the highest power of a numerator is greater than the highest power of the denominator, then to find the limit of this rational function, we have to use the long division method. So we have to divide 1 minus x to the power of 3. We divide it by x squared plus 7x. So what you do is you divide the highest power by the highest power. So we divide x to the power 3 divided by x squared. Don't forget the negative sign. So negative x to the power 3 divided by x to the power of 2 will be minus x. And then perform the multiplication now. Minus x has to be multiplied by the whole term. So minus x multiplied by x squared is minus x to the power of 3. So you write it under minus x to the power 3 up here. And then minus x multiplied by 7x is minus 7x squared. And then you subtract. So 1 minus 0 is 1. Minus x to the power of 3 minus x to the power of 3 is 0. And then and then the remaining will be here plus 7x squared. Okay. Now you divide this highest power by this highest power. So 7x squared divided by x squared is plus 7. And you perform the multiplication. Then 7 times x squared is 7x squared. And 7 multiplied by 7x is 49x. And then you perform the subtraction. So again, 1 minus 0 is 1. 7x squared minus 7x squared is 0. And here we have 0 minus 49x will be minus 49x. Here we cannot divide anymore because the power of the numerator of this term is less than the power of this term. So we will say the rational function plus 7x is equivalent to the answer here on the top, which is minus 7 plus, minus x. So it's minus x plus 7. So this is the answer. And this term is the remainder. So plus, the remainder here is minus 1 minus 49x divided by x squared plus 7x. This is called the remainder. Okay. Now, if we want to find the limit as x goes to minus infinity, so the limit of the first term, so lim minus x plus 7 as x goes to minus infinity, by substitution will be positive infinity. So it will be positive infinity. If you substitute x by minus infinity, then minus times minus infinity is positive infinity, plus 7 is infinity, because infinity is a very huge number. And the limit of the second term, which is the remainder of the long division, here if you see the highest power in the numerator is less than the highest power of the denominator. And if you divide by x squared you will get the 0. So the limit here will be 0, because if the highest power of the numerator is less than the highest power of the denominator, then the limit as x goes to minus infinity is 0. Okay? So, so in this case, the limit of this rational function is equivalent to infinity. So we will say the final answer here, lim as x goes to minus infinity of this function 1 minus x to the power of 3 divided by x squared plus 7x to the power of 5 equals infinity to the power of 5, that is infinity. Infinity to the power of 5, which is infinity. So as x goes to minus infinity, the answer will be infinity. Okay? So this is the way we use the long division. Now there's one more question here. Okay, again, here if we look at the highest power in the numerator is minus 1, and the highest power in the denominator is minus 2. And minus 1 is greater than minus 2, right? Consider the negative sign. So again, we have to use the long division. So we have to divide x to the power of minus 1 plus x to the power of minus 4 divided by x to the power of minus 2 minus x to the power of minus 3. Okay, so you divide the highest power by the highest power, x to the power of minus 1. If you divide it by x to the power of minus 2, what will be the answer? The answer will be x. And then when you perform the multiplication, x times x to the power of minus 2 is x to the power of minus 1. And here we will have minus x to the power of minus 2. If you multiply x by x to the power of minus 3, you will get x to the power of minus 2. And now you perform the subtraction, so this and this will be 0. And x to the power of minus 4, we write it. And minus minus becomes plus x to the power of minus 2. Now you divide the highest power here, x to the power minus 2, by the highest power, which is x to the power of minus 2, you will be 1. So plus 1. When you perform the multiplication, you will get x to the power minus 2 minus x to the power of minus 3. And again, you perform the subtraction. See here, x to the power minus 4 and x to the power minus 2 minus x to the power minus 2 is 0. And then 0 minus minus becomes plus x to the power of minus 3. Now see here, the highest power is minus 3. The highest power here is minus 2. And minus 3 is less than minus 2, so we stop the long division. Then we will say the rational function we can write it as x to the power, we can write it as, the answer is in the top here, which is x plus 1 plus the remainder. Now the remainder is x to the power minus 4 plus x to the power of minus 3 divided by x to the power of minus 2 minus x to the power of minus 3. Now, let's see the limit of the first term and the remainder. So the limit of the first term as x goes to positive infinity is infinity. By substitution, it's infinity. Okay, and the limit of the second term as x goes to positive infinity should be 0. Why? Because the highest power in the numerator is minus 3, and the highest power in the denominator is minus 2. Minus 3 is less than minus 2, then this limit will be 0. Then the limit of the whole function here, the rational function, will be is equivalent to infinity plus 0, that is infinity. So we'll say the limit of the whole function, which is x to the power minus 1 plus x to the power of minus 4 divided by x to the power of minus 2 minus x to the power of minus 3 as x goes to infinity will be infinity plus 0, that is infinity. So this is the way we solve or find the limit of the rational function as x goes to infinity or minus infinity if the highest power in the numerator is greater than the highest power of the denominator. We use the long division. I hope you understand now the procedure. Okay. Thank you very much.